Hello College Algebra student, this video is for chapter 5.3 part 2. We are wanting to graph or actually sketch a graph. It's not actually graph, sketch polynomial functions. So the major things that we need to know is factor the polynomial into factors and then find the zeros. But in order to prepare to graph, other than finding the zero, we also need to notice something called the multiplicity of each zeros. Multiplicity means how many times that zero repeat in the factoring. So if it is a even multiplicity, that means it is like x minus 2 square, or x minus 3 square, or 4 times. Then the means that particular zeros only touch or tangent to the x-axis. It will not pass through. It's bending, it's turning on the x-axis. It's a turning point. If it is an odd multiplicity, that means the graph actually will intersect the x-axis. It would go through it. So this is important. You would graph it, and in my example, I actually would do graphing all those polynomial that has already been factored, right? So the one step of factoring is eliminated already. So if you want to know how to factor them, look at part 1. After you find all the zeros and determine all the multiplicity of each zero, the second thing is to know the end behaviors of the polynomial functions. How do I determine end behavior? The end behavior is determined by what? Leading term. So even after they are factored, you have to find the leading term, because the leading term tells you how the polynomial behave when it is really big or small. And then if possible, look at symmetry. So see if there is any if it is an even function or odd functions. Because sometimes if it is even or odd, then you can just do one side and then just copy the other one. And then you also find a point, at least find one point, which is the y-intercept. That's easy to find. Okay, so x-intercept are the zeros, y-intercept is 1 point, and then look at multiplicity and look at end behavior. And then you gather all this information, you can sketch a graph, cannot graph accurately. Okay. The first example is I have this polynomial function. It's 2x minus 3 squared times x plus 5. So this is not a quadratic because you have the x minus 3 squared, but you also multiply x plus 5. But it's all factored, right? So first of all is zeros. Because it's all factors, so the zeros would be, and also the multiplicity. So 0 would be x minus 3 equal to 0, x equal to 3. Multiplicity is, for this one, multiplicity is 2, because it's square, it's double. Another 0 is x plus 5 equal to 0, so x equal to negative 5. But the multiplicity is 1, because it's power 1. So this would be tangent to x-axis. This would be, so it turns in the x-axis, this would go through it, it doesn't turn. And so the second thing is end behaviors. To do end behavior, we have to do the leading term, because the leading term determines end behavior. Leading term would be negative 2 x squared times x. So it is negative 2 x cubed. Now, so looking at this leading the end behavior of this power function is the same as the whole polynomial function. It's very interesting. So what would this be? This is a odd power, so it should be like the left and right, left down, right up, but you have a negative reflection, so it would be, you can think of it as left up, right down, right? So you can think of it that way. So technically, you should write the end behavior this way. End behavior when x approaches infinity, y approaches negative infinity. When x approaches negative infinity, y approaches infinity. They go opposite direction. So we have end behavior. Is there any symmetry? I don't think so. They have different zeros on different sides, so it's not symmetry. So find y-intercept. So set x equal to 0. So that means y now is become -2 times -3 square times 5 is it a positive negative? This is positive 9 times 5 is 45 times negative 90. So there's a very big, so it's a y-intercept. So we collect a lot of this information. We know it is like that. We're ready to graph. Oh, do I have enough space? Not enough space. So just graph it here. The important thing is to do the end behavior first. Is like this side and this side, right? And then do the zeros. Is 3 and -5. 3 and -5 here. So start from left side, so go down. But this is this is -5. It's multiplicity of 1, so it has to go through it. After you go through it, it will go up to -90, very down, and then up. It will go through this, but what happened is this is x is equal to 3, so this would bounce back, right? So this would be tangent, turn. And that's how you graph it. Okay, it's not exactly, we don't know if it turns here, but it may go down more or something, but that's the best we can do. At least the shapes, so it will go down. Second one, f of x equal to 8, x plus 1, x plus 3, x minus 4 cube. So what do we have? First of all is 0 first, and also multiplicity. 0 is x equal to -1. Multiplicity, multi, this short form, equal to 1 because it's power 1. X equal to -3. Multiplicity is power 1 also odd. So all of them are odd. X equal to 4, this one, right? X equal to 4. Multiplicity is 3, all odd. For odd power or odd multiplicity is not tangent. It would go through it. Second thing is end behavior. So to do end behavior, I need a leading term. Because these are all factors, so the leading term, we need to multiply it out. So be 8x times x times x cubed. So that would be 8x to the 5th. Odd function, odd power, positive. So that means the end behavior like this. Drop on the left, rise on the right. So write down the end behavior. Is when x approaches infinity, y approaches infinity. When x approaches negative infinity, y also approach negative infinity. Like on the left side, both go to infinity. Is it symmetry? No. Even the 0 are not symmetrical. So let's graph it now. Oh, we have to do the y-intercept. Let's do the y-intercept. Y-intercept, it is just plug in x equal to 0, right? X equal to 0. So y is equal to 8 times 1 times 3 times -4 to the cube. So it's a really big number. Like, gosh, it's a negative number, right? Negative, okay, so 24 first. No, 24 times -4 cube. -1536. Y-intercept. Now, we're ready to graph. Oh, this is just a sketch because we cannot go to negative 1000. So mark out all the zeros. We have negative 3, the furthest, and then a negative 1, and then a 4, right? Now all of them, and then the end behavior would be like this, coming from the negative infinity side, going to here. So when you go, first you go to negative 3, it has to cut through. And then we have to come down. And then we have to go all the way down, 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 down. And then we have to go up, cut through. All of these have to cut through. That's it. That's how we graph it. Not exactly, but it's a sketch. The last one. So what are the first things? Zeros and multiplicity. 0 is x equal to 0 from the left. Multiplicity is 3, right? Power 3. So this would cut through. X equal to negative 2. This multiplicity is 1 because there's no power. There's 1. X equal to 2. This multiplicity is 2, which is an even number. So this would be a turn point. It would be a turn tangent. So these two are cut through. This is a tangent. And then we have what? And behavior, right? So need a leading term. Leading term. So you would do negative 4x cubed. Anytime you have an x, you take it x 1 time, x 2 times. So what do I have? A 4x to the 6. Negative 4x to the 6. So x to the 6 is an even power. So for end behavior. So we would just look at this leading term to look at the end behavior. It should be down, down, right? Both left and right is down. So this is the end behavior. And technically we would write when x approaches infinity, y approaches negative infinity. When x approaches negative infinity, y also approach negative infinity. Both sides go down. Left and right go down. And then what else do I have? Do I have symmetry? Maybe because this one is a square, but this one's only have 1. So probably not. So no symmetry. Y-intercept. Plug in 0 for x. X equal to 0. So y would equal to negative 4 times 0. Oh, the whole thing goes away, right? 2, negative 2 square. It doesn't make sense. Doesn't need to do. So it just goes through 0, 0. So that's really good. So we're just going to do a quick sketch. Write all the... So it's negative 2, a 0, and a 2. And we know that it is coming from here and going down here. So from the negative side, it would go to negative 2. For negative 2 is cut through, right? Because the multiplicity is 1. And then it would go to 0, also cut through because it's odd, right? And then it would go to 2, but it is bounced back. It would touch it a little bit and then bounce back. It would not go through. So there you go. We have the graph. That is the end of 5.3, graphing polynomial. For to check the answer, you can use decimal. Okay. So we'll do 5.4 in the next video.